Okay, so last family. And this group, both amines and amides, they are the first family of organic compounds that contains nitrogen. So when you have nitrogen in a compound and you're following the rules, then nitrogen has 5 valence electrons. So when it's in an organic compound, that means it can make 3 bonds, okay? So we've seen carbon, which makes 4, oxygen, which makes 2, and now nitrogen, which makes 3. And it says they have a pungent odor. So pungent implies, again, not a good odor. So we are carbon-based organisms. We are also, anything living is a nitrogen base, has nitrogen to it as well, because we're made of proteins also. So in grade 9, when you did ecology, you would have done the carbon cycle and the nitrogen cycle. So when something dies, and one of the terms we can use for a dead human body is a cadaver. So the molecules produced by decaying organisms are amines. They're called putrescine, cadaverine because they smell awful. Amines are also found in fish. So if you are a fish or seafood eater, we often put lemon on them. These are weak bases, so it sort of neutralizes the base and gets rid of the quote unquote fishy smell, okay? So perhaps you do that as well. But again, these are going to be important if you also are into biology or biochemistry as well, because an amide linkage is what's found in a protein, so you're going to talk about those again. So amines are a little bit simpler than amides, similar with what we just did. Carboxylic acids are a little bit simpler than esters. So when you name an amine, you can classify them as primary, secondary, or tertiary based on how many groups are attached to the nitrogen, because this is going to influence whether they can hydrogen bond or not, so that influences their properties. So here, primary has 1 carbon group, and remember I said this is a short form for primary. Secondary has 2, tertiary has 3. It doesn't affect how you name it at all, it only affects the properties. Ooh. So up till now we've done OH. Part of hydrogen bonding is NOF, right? You can also do nitrogen. So now we have NH. there's two IUPAC ways to name these. I think your textbook mostly uses amino, but you might see the other way as well. So you count the number of carbons in the longest chain. So here, this is the simplest. So there's meth. So it's methane, and then you simply put amino. The other way is more like what we've been doing, where you name the longest chain and add an ending. So this is meth. So methane, drop the E and add amine. Actually, forget. Yeah, it sort of mixes it up. So you can choose to do this either way, okay? Amines and amides actually are not super difficult to name because you often will see if there's more than one thing attached to the nitrogen, we put an N in front of it. So like the next examples, like N-methyl, that means that on the nitrogen, there's a methyl, okay? So there are pros and these, even though they're at the end, that doesn't mean that they're the most difficult or anything like that. So for example, like this one, N-methyl. So on the nitrogen, there's a methyl. You can also have, so nitrogen can make three bonds. So you can have three things. Let me just try. If you printed the note off and you guys want to sneak that in there, that picture. You can have a number. Okay, so you can, the nitrogen doesn't have to be at the end as well. Yes. These are separate. Sorry. We're going to draw this, then we're going to name this. So I think you can just kind of do the same thing. Like there's space over here, kind of put it over to the right. And then the other three are next. Yeah. So it's up to you. If you want, it says N-methyl first. So draw an N, attach a methyl. They're often drawn like this to try to emphasize the pyramid shape, that like the Vesper shape, but you don't have to do that. You just need three, okay? So this, that's a terrible bond, is bonded to the nitrogen. And then the propane gets to go with the amino because it's the longest. It's also bonded to the nitrogen, but this too goes with the amino. So that means that wherever you draw the propane, so some people will draw it underneath, attached to number 2. You might see it like this. Attached to number 2, whatever you like better, okay? Let me just put the ticks and I'll write some words here. So similar with carbon, nitrogen needs 3 bonds, so you can fill in just ticks, or you can write in the H if you've been doing that. You can do condensed, whatever you've been doing. Yes, Emma. 2 means amino. And then in brackets, I put an N, capital N. And then attaches. On. Second. And I did like the short form. Carbon. You're welcome. Okay, so now over here, it's up to you if you want to put the ethyls first or you want to put the aminobutane part first. So again, the longest chain, just like we've been doing, is the parent. So you either write aminobutane or butanamine at the end. And then this nitrogen has this group attached and this group attached to it. So these are both 2s. So you can write NN and then diethyl, or if you want, every time something's attached to the nitrogen that's not the parent, you can just do N has an ethyl, has another ethyl, and then the longest chain, which is always the most important, gets the amino part. Sometimes when it's attached to the end, we don't write the 1. But again, if you want to put that in there, you can to emphasize it. You can also write this if you prefer the amine part at the end. But your textbook definitely uses both. Okay, so just pick one, whatever you want to use, but make sure you recognize both. They both say A, like AMIN, so that's an amine. Yes, Andrew. Yes, but you would have to do NN. Okay, and then the NA. Both ethyls are on the N, okay? Yes. I don't care. And unfortunately, your textbook, I just checked, it mixes them both, so I think, to be honest, I think most people usually do this because then it's like an amine and the word amine, so, but it's up to you. Yes, Jovan. Yes. So similar to the other ones, right? Butanal, you don't write the E, you write AL. Butanol, you don't write the E. So maybe if you're used to that even, you might like this better. It's up to you. Okay, so let's do some more. All right, so aminobutane, again, sometimes they're just assuming that you know that it's on number 1. But if you want to write it in there, you can. I don't know why I'm obsessed with butane. It doesn't matter if you put the N on the left or the right. Okay, you just need to make sure carbon has 4 bonds and nitrogen has 3. So 1, 2, 3. Or if you're a condensed person, you can do it like this. Okay, so this, yes, Lauren. You just have to look at the number. So this one said number 2. Yes. Actually, to be honest, you could have drawn that one even like this with the N on the bottom. It just has to be on number 2. Okay? So this one, 1, 2, 3, 4, 5, 6. So 6 is hex. So hexanamine. And again, it is on number 1. Or aminohexane. And then for N-ethyl 1-aminobutane, I'm going to do it backwards, okay? So I'm going to draw the bute first. I'm going to put the N over here. Ethyl. Done. Yeah, just, you don't have to, just because of the Vesper shape. Yes, sorry. Yeah, so if it was 2, then it would have to go here. That's right, because this is number 1. You could have done this, actually. Doesn't matter. Just has to be on number 1. So annoying-ish, because there is a lot of ways you could do it, but then the chance of you picking a right way is a little bit increased as well, okay? All right, so for the properties, if you printed the note off, the stuff that's written on here is already typed in, okay? I fixed it. So amines have higher melting and boiling points than similar sized hydrocarbons. C, N, and HN bonds are polar. And then, like I said, it's already here. Primary and secondary amines have a free NH, which means they can form hydrogen bonds with themselves. Okay? So if you want to highlight that, you can. But so on that, where we labeled, were they primary, were they secondary, were they tertiary, then tertiary don't, right? Okay. So NH bonds can form hydrogen bonds. Therefore, smaller amines are soluble in water. Now, this is ruthless, okay? This point here. So again, for me to ask you to compare alcohols and primary or secondary amines that's not an expectation, okay? But just so you know, because of the electronegativity of oxygen, then it's more of a polar bond. But again, I wouldn't make you compare 2 of them that are so close together. But the boiling points of primary and secondary amines are higher than tertiary because of hydrogen bonding. So again, tertiary has no free NH, which we highlighted on that first section of this note. So when we get to acid-base equilibrium, we're going to use ammonia, which is NH3, as a very common weak base. And then derivatives, which means you use ammonia to make amines, they are also going to be considered weak bases or proton acceptors if you watched were into it in grade 11. Okay. You good? Okay. Okay, so to do the reaction, just watch this for a second, okay? So you have this, remember the fancy word for it is an alkyl halide. So you need an alkane plus a halogen, and then it's basically substitution. So you start with ammonia. Ammonia has 3 hydrogens, pick one, doesn't matter, and then they switch. So the I switches with the H, and this goes on, and then you get HI left over. So you can do it again and again. You can take another one with a primary amine, take one of the H's off, put a carbon group on, get secondary. Take the secondary amine, take a hydrogen off, make a tertiary amine, okay? So the same principles of substitution. Single bonds only, 2 reactants, 2 products. You're not breaking any double bonds. All right, so on to amides. So amides are similar-ish to an ester. So if you want to do the two-color thing again, okay, because you'll see there is this double bond O part, which is going to break, we're going to break the name into two. So I'm even going to use the same colors, okay, but you don't have to. So we have C double bond O, but this time amines and amides have nitrogen instead of oxygen. But again, you need this part is the amide part. So the carbon with the C double bond O has to have the single bonded N, just like an ester, C double bond O and the O go together, okay? So these are going to be important because this is the linkage that forms in a protein. In biology, you might call it a peptide linkage, but it's the same thing. So you have a carboxylic acid, so part of an amino acid, and another part of an amino acid is an amine, so amino acid. They have two ends, and they come together to make an amide, or a peptide, which is a protein. So we're gonna do the same thing. The first part of the name comes from whatever's bonded to the N. You count the number of carbons and use the ending YL, just like an ester. Except this time now you could have a bunch of things attached to the nitrogen. So you might have to do like N-methyl, like same as we just did. And then the one that has the double bond O gets the fancy ending. So an ester was anoate. This one is going to be amide. Drop the E, change it to amide. Same thing with esters. It could go, like the N could be on the left or on the right-hand side of the C double bond O. That's not what matters. It matters what's connected to the N and what's connected to the C double bond O, okay? So if you want to do the same thing like we did before, this part you write first, the C double bond O part you write second. Since this nitrogen only has an ethyl, you can just write ethyl. If you would like to keep it looking the same, you can put N-ethyl, that's fine. Okay? But you don't have to when there's only one thing. Then this one, don't forget this carbon here. 1, 2, 3. So prop. Again, we don't say propamide. That sounds weird. We say propanamide. Okay? You can put dashes in between if you want. You can leave a space. It doesn't really matter. Okay, so now this one, it doesn't matter if you put it on the right or put it on the left. But again, when you read this, you see the propyl first. So most people would draw the propyl. It's connected to a nitrogen. So is a methyl. Actually, I won't even draw it. So is a methyl. Make some ticks. Okay. The only unfortunate thing here is now you have some carbons over here, but they don't get the double bond O. It's the bute part. Okay. So the bute is connected to gets the amide, this bute part here, right? So it is going to have the oxygen. So you still want to make sure you've got this linkage here, we call it, okay? And that you're putting it with whatever here. So this is the 4 chain, right? 4 carbons. So connect it to the N, and then that first carbon gets the double bond O. Not one of these. Okay. For some reason, the note is backwards. That's weird. Like this one's on the right and this one's on the left. I don't know why I did that. Okay, so this, it says, if you printed the note off, it says this one first, so I'll do this one first. So again, propyl is 3. Attached to the nitrogen. And then meth, which is 1, is the amide, so that gets the double bond O. And then go back in. Carbon needs 4 bonds, nitrogen needs 3. For the other one, there are 2 things attached to the nitrogen. We didn't really talk about this, but so this is 1 carbon, which is meth. This is 1, 2, 3, 4, 5 pent. And normally what we do is we do it alphabetical. But if you write N-pentyl first, I wouldn't take marks off, okay? So this should be N-methyl, N-pentyl. But if you wrote N-pentyl, N-methyl, that's fine. And then the C double bond O is part of the prop. 1, 2, 3. Okay, so there is one weird thing about amides because of the nature of nitrogen. You can actually, you don't need something attached to the nitrogen. So somewhere, just sneak this little one in, okay? So you could have this, for example. So there's still the linkage, but there's no carbons attached to the nitrogen. So there's no YL part. It's just 1, 2 ethanamide. Ooh. Oh, and it's actually later in the reactions. I was going to say, it's because it comes from, or the very first step in an amide synthesis would be using ammonia, which doesn't have nitrogen, or doesn't have carbon. So it could be just hexanamide, heptanamide, whatever, however many carbons. So the good news is, like, when something is attached to the nitrogen, it'll say N-methyl, right? So the N nitrogen has a methyl. The N nitrogen has a pentyl. Okay, so similar to esters, but a little bit different. Okay. So again, if you printed the notes off, this is already typed on there, okay? So amides are generally insoluble in water. So again, the same thing with an ester. They get pretty big pretty fast because usually there's more than one carbon chain. If it's an amide that has NH bonds, like this one does, and it's small, then it can hydrogen bond. They are polar. CN bonds are polar. CO bonds are polar. So if they're small, then they will be soluble in water. But if there is no NH bond, so tertiary ones, like we highlighted in the first slide, then solubility will decrease because it can't form hydrogen bonds with water and not as easily with, can't form hydrogen bonds with itself and not as easily with water. But again, if you printed the note off, this is already there, okay? Yes. Depends on if there's an NH. So some amides are soluble and some aren't. Or the solubility decreases. So you have to look for, like, this one has no NH bond, so it would not be soluble. This one has one. This one has two. Okay. But again, to compare the comparison will be obvious, like nonpolar, polar, because it's hard when in grade 11, when we do the solubility table, it's like soluble, insoluble, and it's really sort of a gradient, more of a gray area. Okay, so the reaction to make an amide is a condensation reaction because you do make water. If you are going to take biology, you can put for yourself that in biology you're going to call this a peptide linkage. Okay, it's the same thing that happens in the synthesis of proteins. So we have a carboxylic acid. And again, it's the colors here. It's not like the carboxylic acid is like, okay, I'm going to give my OH. Okay, you give an H, but that is a good way to think of it. So then, because the C double bond O part is unique to the acid, so you can think of it just like the synthesis of an ester, okay? And then, so this is ammonia. It could also be a primary or secondary amine. And then you would get the corresponding amide. So you lose the OH from the acid, you lose the H, they come together, you make water, condensation, reaction. And this is how proteins are made, over and over again with amino acids. They have an acid end, they have an amine end, and they come together and make water. So this is that simple one that we just did. There's nothing attached to the nitrogen, so this would just be ethanamide from ethanoic acid. So then the hydrolysis reaction, so esterification could go in the other direction, so can this one. But this one, it says proceeds slower, and that makes sense. Can you imagine if every time your proteins in your body came in contact with water, they just started to break apart? Obviously, that's not good for life, okay? So in grade 12 bio, you'll talk a ton about chopping up proteins, should you take, and the enzymes required and all that kind of stuff. Should you take first year bio? It's the same thing, cellular bio. So, not the same thing, but like protein synthesis, protein oxidation is a big part of it.